A bag of bone char costs $3. $3. You can buy it at any feed store, any gardening supply, any online retailer. It is nothing more than animal bones heated to extreme temperatures until they become pure porous carbon laced with crystalline hydroxyapatite. And when you pour contaminated water through it, something remarkable happens. The fluoride vanishes, up to 90% of it, gone, not masked, not diluted, chemically captured, and locked inside the mineral structure of the char itself. Peer-reviewed research published in the journal Industrial and Engineering Chemistry Research confirmed that bone char's adsorption capacity is 2.8 times greater than commercial activated alumina and 36 times greater than commercial activated carbon. That is not a marginal improvement. That is a different category of performance. And a federal judge just ruled that the fluoride this powder removes poses an unreasonable risk of lowering children's IQ. Yet in most of the country, you are still drinking it. Stay with me. They buried the techniques. We dig them up. The use of charred bone for water purification is not new. It is one of the oldest water treatment methods ever documented. In Tanzania, communities have used bone char for generations to remove fluoride from naturally contaminated groundwater, where concentrations can reach levels 5 to 10 times higher than anything found in American tap water. In India, ancient Sanskrit texts dating to 2000 BC described water purification using charcoal, sand, and gravel filtration. The Susruta Samhita, one of the foundational texts of Ayurvedic medicine, laid out specific instructions for filtering water through layered earthen vessels. Across the ancient world, the Egyptians placed charcoal inside clay storage jars. The Greeks developed cloth filtration sleeves. Hippocrates himself designed a fabric filter around 400 BC to trap sediment after boiling. Different continents, different centuries, different civilizations, zero contact between them, and they all arrived at the same conclusion. Charred organic material purifies water. They did not understand adsorption isotherms. They did not know about hydroxyapatite matrices or ion exchange mechanisms, but they could observe the result. Villages that filtered survived. Villages that did not suffered. In 2007, researchers at the Instituto Potosino de Investigación Científica in Mexico published a landmark study on bone char fluoride adsorption. They found that maximum fluoride removal occurred at pH 3 and that performance decreased nearly 20 times as pH rose to 12. The study confirmed that bone char's hydroxyapatite structure, which makes up 70 to 76% of its composition, acts as a molecular trap. Fluoride ions swap places with hydroxyl ions on the crystal surface through a process called ion exchange. In 2021, a study published in the International Journal of Environmental Research and Public Health tested a gravity-fed sandbag filter loaded with a combination of 1 kilogram of bone char and 1 kilogram of granular activated carbon. The result was 100% fluoride removal from water containing 5 milligrams per liter of fluoride, sustained for 165 minutes of continuous filtration. 100%. From a gravity filter you could build in your backyard with materials costing under $15. The University of Southern Queensland conducted a comprehensive review in 2019, confirming bone char as an environmentally friendly and cost-effective sorbent for fluoride removal, finding optimal production temperatures between 500 and 700 degrees Celsius with a 2-hour residence time. The science is not ambiguous. It is settled. Now, before I continue, everything I just described, every ancient technique, every suppressed method, every DIY solution the filtration industry does not want you to know, it is all compiled inside the complete forbidden outdoor vault. Water purification, fire starting, food preservation, shelter construction, cleaning formulas your great-grandparents used before the chemical industry replaced them with subscriptions. The link is in the description. If this knowledge matters to you, the vault is where it lives. Stay with me. Here is the part they do not want you to hear. The global water purification industry is valued at over $45 billion. The bottled water market alone exceeded $350 billion in 2024. The home water filtration market hit $20 billion and is projected to reach $50 billion by 2037. 33. Nestle, Coca-Cola, PepsiCo, Danone. These are not water companies. They are recurring revenue machines. Their entire business model depends on one thing: you believing your tap water is dangerous and that only their product can save you. A reverse osmosis system costs $150 to $500. Replacement membranes run $50 to $100 every 2 to 3 years. Replacement filters every 6 to 12 months. A basic under-counter fluoride removal system runs about $300 installed, with annual filter replacements costing $80 to $120. Now consider bone char, $3 a pound. A single pound can treat hundreds of gallons. A gravity filter built from 2 5-gallon buckets, some sand, and 2 pounds of bone char costs under $15 total. It removes fluoride, lead, cadmium, mercury, arsenic, radionuclides, pesticides, and chlorine. It requires no electricity, no plumbing, no subscription, no replacement cartridge shipped to your door every 90 days with a credit card charge you forgot you authorized. You cannot patent bone. You cannot patent charred bone. What you cannot control, you have to bury, and bury it they did. Not through outright bans. That would be too obvious. Instead, through regulatory architecture designed to make bone char invisible. The NSF, the organization that certifies water treatment products in the United States, charges tens of thousands of dollars for product certification. A small bone char producer operating out of a ranch cannot afford that process. So bone char filters rarely carry the certifications that big box retailers require for shelf placement. Homeowners associations in thousands of communities restrict or prohibit visible water treatment systems that are not commercially certified. Municipal water regulations in dozens of states mandate fluoridation with no opt-out provision for individual households. Until 2025, not a single state in America had banned fluoride addition to public water. The fluoridation chemical most commonly used, hexafluorosilicic acid, is a byproduct of the phosphate fertilizer industry. It is industrial waste, repackaged as a public health measure and sold to municipalities across the country. The fluorosilicic acid market alone is valued at over $500 million. The sodium fluoride market exceeds $700 million. This is not a health program. This is a waste disposal revenue stream with a dental alibi. Now, here is the honest part. Bone char is not a perfect solution. Its effectiveness drops significantly in alkaline water, which is exactly what most municipal systems produce. Cities raise their water pH to 8 or above to prevent pipe corrosion, and bone char performs best in the 6 to 7 range. Real-world fluoride removal with bone char averages closer to 67% in typical municipal water conditions, not the 90% achieved under ideal laboratory settings. Flow rate matters enormously. The ion exchange process needs time. You cannot run water through a bone char filter at high pressure and expect full removal. Approximately 1.5 gallons per minute per cubic foot of media is the maximum effective rate. Higher than that, and fluoride slips through, and bone char does eventually exhaust. A point-of-use filter treats roughly 5,000 gallons before the media needs replacing. A whole house system handles around 100,000 gallons, which for an average family of 4 means roughly 1 filter change per year. It is not magic, it is chemistry, and chemistry has constraints. But even at 67% removal, bone char outperforms every commercially available pitcher filter on the market, none of which remove any meaningful amount of fluoride at all. Here is what you need. Bone char 8 by 24 mesh, available from any water filtration supply company or livestock supply store. 2 food-grade 5-gallon buckets, 1 standard spigot, a drill, coarse sand, fine gravel. Layer the bottom bucket with the spigot installed near the base. Place a piece of unbleached cotton fabric over the drain hole inside the upper bucket. Add 2 inches of fine gravel, then 4 inches of bone char, then 2 inches of coarse sand on top. Pour water into the upper bucket slowly. Let gravity do the work. Flow rate should be no faster than 1 to 2 gallons per hour for optimal fluoride capture. Total cost $12 to $15. A family in Abilene, Texas, built this exact setup after their municipal water tested at 1.2 milligrams per liter of fluoride. After filtering, their water tested at 0.3 milligrams per liter and 75% reduction. Their annual cost for replacement bone char is $6. Their neighbor spends $340 per year on a commercial reverse osmosis system that wastes 3 gallons of water for every 1 gallon it produces. Same street, same water. One family pays $6, the other pays $340. The Egyptians filtered water through charcoal in clay vessels 3,000 years ago. Indian physicians prescribed sand and gravel filtration in texts that predate the Roman Empire. Tanzanian villages have used bone char to defluoridate groundwater for generations. In September 2024, a federal judge ruled that fluoride at current recommended levels poses an unreasonable risk of reducing IQ in children. In March 2025, Utah became the first state in American history to ban fluoride from public water. Florida followed weeks later. 62 communities serving over 9 million people have ended or suspended fluoridation since that court ruling. 18 states introduced legislation to ban it in 2025 alone. The science is settled. The history is undeniable. A $3 bag of charred bone removes what a $350 billion industry sells back to you in plastic bottles. This knowledge did not disappear. It was buried under $500 billion of marketing, lobbying, and regulatory capture. Your great-grandmother knew. She filtered water through charcoal and bone ash in a ceramic crock on her kitchen counter. Now so do you. Every share preserves what they tried to erase.